Hi everyone, welcome to the Dart Training channel. My name is Alvaro and I am an electrical engineer dedicated to several issues in the area of maritime terminals that handles flammable liquids and his dangerous vapors, which are, as everybody knows, susceptible to several sources of ignitions that may cause tragic accidents. My intention with this presentation is to promote a sample of my training style, and in this case, I will approach the specific theme of explosive atmospheres. Another goal is to invite every technician to appreciate the content and, if possible, to give me your very welcome feedbacks and suggestions, and thus allowing me to add improvements to the work. Anyway, first of all, our main target is to preserve lives and material losses, simply by providing information and support for those who work with risk management. So let's go to the subject, trying to show in a synthetic vision the main concept about the explosive atmospheres. Enjoy this video sample and don't forget to pay attention to my last message at the end of this video. So, what really is an explosive atmosphere? Let's take a first approach to the definition, taking as reference an imaginary line that shows relative concentration of flammable and combustible products. From 0 to 100% of product for an oxidant concentration, in this case O2, fixes around 21%, which is the oxygen concentration in atmospheric air. The limits for the concentration of flammables are naturally defined, from which flammability and explosion are no longer possible for natural, physical and chemical reasons. We then have the lower flammability limit and the upper flammability limit, as indicated in our diagram. It's important to note that all limits may vary, depending on the greater or lesser presence of oxygen and temperature variation. The flammability zone is then defined as a configuration of concentrations of the mixture of hydrocarbon vapor and air within the concentration limits susceptible to ignition. Within natural variation of the presence of O2 in the vapor spaces, with the highest oxygen content, the flammability expands. That is, the lower limit of concentration, or LEL, may smoothly decrease a little bit, and the upper limit of flammability, or UEL, may increase a little bit more. As we proceed in the search for a more accurate understanding and in the understanding of the dangerous contingents of explosive atmospheres, it would be necessary to continue talking about at least 5 important factors that, in short, are dependent variables of the available energy, therefore of the temperature. These factors are then nominally evaporation, gas or vapor density, flash point, ignition point, and vapor pressure. As we said before, this is just a sampling of our training style, and obviously we didn't aim to exhaust this topic. These considerations and the wide-ranging topic are better elaborated in our extensive training package deal. The most expressive variables such as vapor pressure, flash point and ignition point are seen in great detail in Module 2 of our training on electrostatic discharge control, especially in the topic that addresses the attention to handle the products. Well, dear professionals, so we concluded this short presentation, hoping it was useful for you, and that is why I invite all of you to leave your comments, likes and subscriptions on the channel. Be sure that it will be a great incentive for us to contribute with new videos in English. Thanks for watching and see you in the next video.